Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we learned question number 2 of exercise number 2.7 related with the topic of exponential differentiation. Exercise number 2.7 related with chapter number 2 differentiation FSC part 2 mathematics. In today's video, I am going to solve question number 3 of the same exercise number 2.7 related with logarithmic differentiation. So let's move toward question number 3. It tells that use any suitable rule of differentiation to perform dy by dx for the following function. Part number A is y is equal to log of 3x square plus 7 to the base 10, and that tells the derivative and find the derivative of this function. Remember, if we have a function in the form of just like y is equal to log of x to the base a, so we can write this type of function according to the rules of logarithm, that log of x to the divided by log of a. This log of x to the base a can be written as log of x and divided by log of a. Now after this, if we differentiate both sides, so it becomes dy by dx is equal to 1 over log a actually constant. So take it outside of 1 over log of a, and derivative of log of x is 1 over x. So it means that dy by dx will be actually equal to 1 over x log of a. So this will be the derivative of log of x to the base a. Now move toward y is equal to log of 3x square plus 7 to the base 10. So what will be the derivative of this function? So derivative will be dy by dx will be equal to 1 over x. So x is actually 3x square plus 7 according to this formula. 3x square plus 7 and log of a. Log of a, the formula is log of a is actually 10. So log of 10 multiplied derivative of this inner function will also be included. So derivative of 3x square and plus 7. So the result will be 1 over 3x square plus 7 multiply log of 10 and multiply derivative of 3x square will be just 6x and derivative of 7 is 0. So the result will be 6x divided by 3x square plus 7. Over here we can write it log of e to the base 10. We can also write. So by moving to the numerator, this e and 10 will replace their places. So it becomes log of 10 to the power e to the base 10. So the result will be 6x log of e to the base 10 divided by 3x square plus 7. Now move toward part number B. It tells that y is equal to log of x square plus 3x plus 2 to the base 10. Find the derivative of this type of function. So the derivative of log of x to the base a we already derived, that is equal to 1 over x log a, either 1 over x log of a to the base e, either log of e to the base a divided by x. We can write derivative of this type of function in these three methods. So move towards solution. Dy by dx will be equal to, first we are writing this form 1 over x. So x is x square plus 3x plus 2, and over here we have log of a. Our a is 10, so log of 10. So this is the derivative. Over here we can write base e. So we can write 1 over x log of 10 to the base e, and also take the derivative of this inner function. So derivative of x square is 2x plus derivative of 3x is 3 and derivative of 2 is 0. So inner function derivative is 2x plus 3 divided by x square plus 3x plus 2 and log of 10 to the base e. We can also write in the form of log of e to the base e over x. So it becomes 2x plus 3 multiply. This is log of 10 to the base e. So by moving to the numerator, both will interchange. So 10 will come to the base and e will come to the exponent. So log of e to the base 10 divided by x square plus 3x plus 2. So these are the three required derivative. We can also write it in the form of 1 over x log a, 1 over x log of a to the base e, log of e to the base e over x. So these are the required result and these are the required derivative for the part number B. Now move toward part number C. It tells that y is equal to log of x square minus 7x under the root to the base 10 plus x cube. Find the derivative of this function. So our dy by dx will be actually equal to 1 over x. So our x is actually under root of x square minus 7x. Under root of x square minus 7x multiply log of a. So log of a is 10 and we can write base e. And 1 over x, so x square minus 7x under root and log of a is 10 over e. And also take the derivative of this inner function. So d by dx of x square minus 7x, it can be written in the form of 1 over 2 because of under root. and plus of d by dx of this function x cube. So after this, you know that derivative of any under root function, just like under root x, is always equal to 1 over 2 into under root x. So the derivative of x square minus 7 power 1 over 2 will be 1 over 2 under the root x. So here x is x square minus 7x, x square minus 7x. Also take the derivative of this inner function. So derivative will be 2x minus 7, 2x minus 7. So derivative is 2x minus 7 divided by 2 into under root x square minus 7 is this function, divided by under root of x square minus 7x multiply log of 10 to the base e, and here the derivative of x cube will be 3x square. After this, we can also simplify this type of function by shifting x square minus 7 under root to the whole denominator. So it becomes 2x minus 7 divided by 2. This under root x square minus 7x will multiply with under root x square minus 7x will give us x square minus 7x, and multiply log of 10 to the base e, and plus derivative of x cube is 3x square, which is 3x square. So this will be the simplified and derivative form of the given part number C. Now move toward part number D. It tells that y is equal to log into sine into log of x. So how can we derive this type of function? Let's suppose if we consider this is x. So you know that derivative of log of x is always equal to 1 over x. But over here the x is actually sine log x. So replace x with sine log x, so it becomes log into sine into log of x. And also replace over here x with sine log x, so sine into log x. So it means derivative of log into this function is 1 over sine into log x. So dy by dx will be 1 over sine into log of x. Now also take the derivative of this inner function. If we suppose log of x is, let's suppose x, so it becomes sine x, and you know that derivative of sine x is always equal to cos of x. So its derivative will be cos time of x, but over here x is log x, so it becomes cos into log x. And also take the derivative of this inner function log x, so its derivative is just 1 over x. So it becomes cos log x divided by sine log x. It will give us cotangent into log of x, so cotangent log x and divided by x. So this is the required derivative for the part number D. Now move toward part number E. It tells that y is equal to log of sine inverse x square to the base 10. Find the derivative of this function. So now again we will use this formula, dy by dx is equal to 1 over x log of a. So our dy by dx will be equal to 1 over x. So over here the x is sine inverse x square. So sine inverse x square multiply log of a. Our log of a is actually 10 over here and base is e. After this, take the derivative of sine inverse x square, d by dx of sine inverse x square, because this is the inner function. You know that derivative of sine inverse x is always equal to under root of 1 over 1 minus x square under the root. But over here the function is x square, so replace x with x square, so it becomes sine inverse of x square will be equal to 1 over under root of 1 minus x is x square, so it becomes x raised to the power 4. So derivative of sine inverse x square will be 1 over under root of 1 minus x raised to the power 4, and derivative of x square, this is inner function, is derivative will be 2x and divided by sine inverse of x square and multiply log of 10 to the base e. So this is the required derivative. This is 2x. This is the required derivative. 2x divided by under root 1 minus x power 4 sine inverse x and multiply log of 10. Now move to the last part of today's lecture, and question number 3 tells that y is equal to log of tangent into x by 2 plus pi by 4. This is a very complex derivative and very complex function. How can we solve this type of function? So let's suppose u is equal to x by 2 plus pi by 4. So after this, if we take out derivative of the u is equal to x by 2 plus pi by 4 with respect to x on the both sides, so it becomes du by dx will be equal to x by 2 derivative will be 1 over 2 and pi by 4 is a constant, derivative is 0. So du by dx will be 1 over 2. Now after this the function will become just like this, y is equal to log of tangent into this function is supposed to be u. Now take the derivative of both sides with respect to x, so it becomes dy by dx will be, you know that derivative of log of x is equal to 1 over x, but over here we will replace x with tangent u, so it becomes log of tangent u will be 1 over tangent u. So it means the derivative of log of tangent u will be actually 1 over tangent u. Now also take the derivative of this inner function, so its derivative will be secant square u, and also take the derivative of u with respect to x. So after simplification it becomes 1 over tangent time of our u is x by 2 plus pi by 4, so x by 2 plus pi by 4. And in the numerator we have secant square u. So by moving to the denominator it becomes cos square u. So it can be written as cos u, and our u is x by 2 plus pi by 4. X by 2 plus pi by 4. Multiply cos of x by 2 plus pi by 4. And after this we have du by dx, which is actually 1 over 2. So we can write 1 over 2 in the denominator just like this. So after this you know that tangent will be sine over cos. So it becomes 1 over 2. In the denominator we have sine into x by 2 plus pi by 4 divided by cos of x by 2 plus pi by 4. This is our tangent into x by 2 plus pi by 4. And multiply, this is 1 over 2. And multiply cos of x by 2 plus pi by 4 and cos of x by 2 plus pi by 4 in the denominator. So cos into x by 2 plus pi by 4 into cos of x by 2 plus pi by 4. After this cos of x by 2 plus pi by 4 will cancel out with 1 cos. So in the denominator we are left with 1 over 2 into sine into x by 2 plus pi by 4, and also we are left with cos of x by 2 plus pi by 4. Now we have a formula that sine 2x is equal to 2 sine x and cos x. 2 sine x and cos x, so it will be equal to sine 2x. So 1 over sine 2x. Our x is x by 2 plus pi by 4. Now after this, inside the 2 will multiply with x by 2 and plus pi by 4. It becomes a sine into x and plus pi by 2. After this we will expand this formula. It will give us a value cos of secant cos of x, because sine x and cos of 90 plus cos of x and sine of 90. You know that cos 90 is 0, so the whole term will be 0, and sine 90 1, so 1 over cos x. And you know that 1 over cos x actually equal to secant x. So the result will be secant x for the part number A. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC Part 2 Mathematics. Thank you.